Look, next we will see what is meant by thrashing and how thrashing will occur. Okay, so what is the cause of thrashing? If you look at this process, okay, the definition of thrashing is the system spends more time on paging rather than executing a program is called thrashing. Okay, so first what will happen? The operating system monitors the CPU utilization. The operating system monitors CPU utilization. If the CPU utilization is low, okay, then we can increase the degree of multiplexing by introducing the new process into a system. So what is meant by degree of multiplexing? The number of processes currently resided in the main memory, we will call it as degree of multiplexing. Okay, so if the CPU utilization is low, that means we have already seen that what will be the ideal CPU utilization rate? 40 to 90%. If the CPU utilization is low, because initially there are less number of processes that are executing in the system, so the CPU utilization, once the execution is done, the CPU utilization will be low. So what will happen? In order to increase the degree of multiplexing, multiprogramming, it will add one more process to the system. Okay, so if we keep on adding those processes to the system, then our degree of multiprogramming will be increased. Degree of multiprogram will be increased. Now there is a problem. What is the problem? If system prefers global replacement algorithm, system prefer global replacement algorithm, this will allows one process to take other process frames, to take other process frames. Okay, so the computer architecture defines the minimum number of frames allocated to each process, minimum number of frames allocated to each process. Okay, so what will happen when they take frames from this particular process, global replacement? Let's look at here. Px is a process which is having higher priority than Py. Py is a process which is having higher priority than Pz. Okay. Now Px needs more pages. Px needs more pages, and these pages have to be loaded into the main memory that has to place in some particular frames. Now what will happen? As we keep on increasing the degree of multiprogramming, the processes will be added to main memory, so that this particular Px will take the frames from Py. Suppose that Px is having 10 frames and Py is having minimum number of frames exactly 5, and Pz minimum number of frames 4. Okay, so currently all of them having their minimum number, but Px needs more pages, so Px implements uses global replacement algorithm and takes 2 pages from Py, so that it will fall below the minimum number. So the number of frames that are increased to 12. Okay, so 2 pages will be sent from main memory to hard disk. Main memory to hard disk. That means there is a swap. Page fault will occur, and this page fault will take the frames from main memory to hard disk. Okay, that is, this particular pages, 2 pages of Py will be moved to hard disk. Will be moved to hard disk. And remember that Px is high priority than Py. Py is high priority than Py is having higher priority than Px. Now what will happen? The CPU will be switched from Px to Py, and Py, the CPU reference the pages which are recently moved to hard disk. That means those 2 pages, okay, out of one page it is reference. Then what will happen? Py needs those pages. So what will happen? Py takes the pages from Pz, takes the pages from Pz. So if it takes 2 pages from Pz, then again it will be 5 pages, and it will be 2 pages. Pz will have 2 pages. Again, every time there is a page fault occurs, the instruction will be suspended, and the paging will be, the page fault process will be done. What is mean by page fault process? The instruction will be suspended. Okay, instruction will be suspended. Then the control is given to your paging hardware. Control is given to paging hardware, and process execution will be suspended until and unless this particular paging hardware you finish the page fault process. Finish the page fault process, that is swap out and swap in. Okay, so every time px will go to paging hardware and wait in the queue, py will go to paging hardware and wait in the queue, pz if also approaches the same thing on p0, which will also does go to paging hardware. So system is continuously executing paging hardware, that is executing page faults, okay, rather than executing the instructions, rather than executing the instructions. See, nothing is happening here, nothing is executing here. Okay, so one process will take the frames, minimum number of frames is violated here. Okay, so one process take the page frames from other process, that particular process take the frame from other process, that particular process will take the frames from other process. Every process is busy in, okay, busy and waiting in paging queue, waiting in paging queue, okay, paging hardware queue, rather than executing its instructions, rather than executing its instructions. Okay, so system will busy in swap in and swap out of these particular pages from main memory to hard disk, rather than executing instructions. So this will leads to decrease of CPU utilization, because nothing is done. Whenever the operating system sees that there is a decrease of CPU utilization, there is a decrease of CPU utilization, it will add more number of processes. It will add more number of processes. Okay, suppose that this will be PQ and PL. These processes, okay, will take the frames from the currently running processes, that is PX, PY, PZ. Will take the currently running processes PX, PY, PZ. So again, these processes also waiting in the queue of hardware. This will again result in complete low CPU utilization. Okay, so adding more number of processes into the system, whenever the CPU is utilization is low, and that particular low CPU utilization will in turn gives more waiting time on hardware, because they take the frames from currently running processes. So nothing will happen, so nothing will happen, no process execution will be done, and system CPU utilization will fall completely. Okay, it will be fall completely. This particular situation is called thrashing. That means system is spending more time on paging, more time on paging, rather than executing uh, instructions. Executing the process instructions is called thrashing. Okay, so the reason for this particular thrashing is by implementing global replacement, okay, and one higher priority process taking the lower priority process frame, even though the process is having no more pages, no more minimum number of pages, no more minimum number of pages. That means when a process is minimum number, having minimum number of pages in the minimum number of pages are frames in the main memory, frames in the main memory. If we restrict the higher priority process to take the frames from lower priority process, we may avoid this particular thrashing. Okay, now let's see the solution to thrash. Okay, first one, we need to implement local replacement algorithm when a process is starts thrashing. Okay, so initially we will implement global replacement algorithm. Okay, but whenever a process px starts thrashing, okay, it cannot steal frames from another process. Okay, so this particular local replacement algorithm will restrict the thrashing to a certain limit, but it cannot eliminate entirely. Okay, so they will go to next solution, that is locality model. What is meant by locality model? Locality model states that a process executing in the as a process executes, it move from one locality to other locality. Okay, so a locality means it is a set of pages that are actively used together, a set of pages that are actively used together. A program consisting of several different localities which may overlap. Let's see the example what is mean by that. Okay, so in a function that consisting of in a program that consisting of multiple functions. Okay, so each function will call it as a locality. Each function will take it as locality, and each function will have its own local variable and its own global variables which are taken, okay, which will be accessed. Okay, so when we exit the function while the program is running, all these data and the code will be running. So a memory references made to instructions to function call and its local variables and its subset of global variables. Okay, so when we exit the function, the process leaves this particular locality, and since local variables instructions of the function are no longer in use, because the local variables of functions will be present in that particular area, that particular function only. Okay, outside of the function the variables will not be used. Okay, so if we change from one function to other function, the locality will be changed. We may come to this particular function when we again call this particular function. Okay, if we call f1 again, we'll come to that particular function, that particular locality. Okay, so during this particular function execution, if we allocate enough frames to a process, okay, to accommodate the current locality, then the page fault will occur only when we change from one locality to other locality. That means we change from one function to other function, then only the page fault will occur. Okay, so if the function f1 having all the pages loaded in the main memory, they will reduce the time to take page fault rate. We reduce the time to take page fault rate. If we do not allocate the enough frames to accommodate the size of the current locality, then the process will thrash, since it keeps in the memory all the pages that is actively using. Okay, so what is the solution? If we are working on a current locality, we should give all the frames to that particular locality, so that the page faults for that particular locality will be reduced, and whenever we change from one locality to other locality, then only the page fault will occur. So this process will reduce the amount of page fault. Okay, amount of page fault. Okay, so if we reduce the time for page fault, then thrashing will also be reduced. Okay.